This is an overview video for College Trigonometry version 3 by Stitz and Ziegler, 10.6.3 Calculators and their inverse circular functions. This is the third of 3 videos for this section. When using a calculator to approximate values, 4 decimal places, they usually tell you how many decimal places to use. We will assume radians, since this book for the most part is using radians other than in story problems. So we're going to make sure that you use your calculator in radian mode, not degree mode. Now I don't have the arc sine, arc tangent, arc cosine because those buttons are actually on your calculator. You might need to look at the same button as the sine to see the arc sine, and again it might be written as this. That's fine. That's the arc sine. That's the notation this book is not using because of its confusion with reciprocals. But find your arc functions. Now as far as what we need to do to find arc cotangent of 2, so you do not have an arc cotangent button, but you can change this to tangent if you remember what to change about it, and that is the value inside. You would then do arc tangent of -1/2 in radian mode, and that would give you a decimal, and then you would go to 4 decimal places and approximate. So as another example, change this arc cosecant to arc sine, and then the inside does the reciprocal. Use your calculator in radian mode and go to 4 decimal places. If they ask for degrees, just change your degree mode and everything else is the same about these. So these questions are very basic. It's just a matter of how to change them to the buttons you do have on your calculator and make sure you're in the correct mode. Solving equations using the inverse trigonometric functions. There's a very big difference between sine theta equals 1/3 and solving for theta and getting theta equals arc sine of 1/3. Specifically, the solutions for sine theta equals 1/3 exist somewhere in quadrant 1 and somewhere in quadrant 2 because all students take calculus. Quadrant 1 and quadrant 2 are where sine is positive. Positive 1/3, somewhere in there. But not just quadrant 1 and quadrant 2, but an infinite number of solutions because you just keep moving around. For example, that value, but you can also get that value, etc. There's an infinite number of solutions. For arc sine, the only answers are going to be quadrant 1 or quadrant -1, and when you have a positive 1/3, it's somewhere in quadrant 1. So we have a problem. We're trying to find an infinite number of solutions, but our calculator only gives us one answer. So what we have to do, we do have to use our calculator unless we want to write, let me demonstrate. If I wanted to write our answers in terms of arc sine, this value right here would just be arc sine, x equals arc sine of 1/3 plus 2k pi. That would give us all of those answers forever. Infinite number of solutions representing all of these right here. Now how would I get this value though? The reference angle is the same. It's arc sine of 1/3. But to get a second quadrant angle, that's pi minus the reference angle. So we would have also x equals pi minus arc sine of 1/3, and that also plus 2k pi. That would be the infinite number of solutions. Now this is without our calculator. If we want to get our calculator, if it's a decimal approximation question, this one didn't suggest that, we would just plug this into our calculator and then we would have some decimal approximation here plus 2k pi. We would still have to take pi minus that decimal approximation and get a new decimal approximation here plus 2k pi. So your calculator only gives you one answer and you need to come up with an infinite number of them. And there's 2 types. There's this one and there's also this one. So the second type you have to know how to get that. Specifically, if you have your reference angle, theta, Quadrant 2 would be pi minus theta. Quadrant 3 would be pi plus theta. Quadrant 4 would be 2 pi minus theta. Know how to work your way around with the reference angles if they're not nice numbers like these. One more example, number 2, find all real numbers for which tangent t equals -2. We know where tangent is negative. Tangent is negative in quadrant 2, so somewhere over here, in quadrant 4, somewhere over here. But where is tangent -2? We would have to take arctangent and get t equals arctangent. I was going to write tangent to the -1. Let's stick to this arctangent of -2. That's the angle, t. It's not called that theta. Now they're calling it t. That's fine. So where is this? Arctangent will give you an answer somewhere in here. So it'll actually give us this value. The calculator will give us a negative number, and to go from that negative number to all solutions representing this, basically we would have arctangent, let's see, t equals arctangent of -2. Now we want to generate all of those. We could add a plus 2 pi, 2k pi, or we can add just a pi to get up to this one, and then another pi to get back to this one, and over and over and over. We can just add k pi and take care of both of these solutions all at once. So again, your calculator will only give you one value, and you need to make sure to know how to work with these reference angles and quadrants to generate all of your solutions.